Hello, my name is Dr. Ruairí, and I'm presenting our work today, an ensemble-based approach to the detection of COVID-19-induced pneumonia using X-ray imagery. The motivation for the work is to assist radiologists in the monitoring and differentiation of pneumonia caused by COVID-19 from other viral causes. It contributes to an ensemble-based approach built on top of transfer learning models to do just that, and as we'll see, the results indicate an improved performance when using ensemble-based learning as compared to a single model. COVID testing, as we're all aware, earlier in 2020, the spread of COVID-19 saw a surge in demand for lab-based testing globally. Our motivation is the use of chest X-rays as a secondary screening solution that can be integrated into pre-existing workflows within the radiology department. It should be noted that not all patients who contract COVID get pneumonia. We're dealing with the subset that do. Pneumonia is a respiratory illness that occurs due to inflammation of tissues in one or both lungs caused by a bacterial or viral infection, with chest X-rays being one of the most commonly used techniques to diagnose pneumonia. However, the diagnosis of pneumonia from X-rays is challenging, as characteristic features within the image can be vague, and often these characteristics overlap with other diseases, adding to the difficulty faced by radiologists in arriving at a diagnosis. The approach adopted is an ensemble-based approach built on top of three transfer learning models that take chest X-ray images as input and automatically classifies them into one of three distinct classes: normal, pneumonia, non-COVID, or pneumonia COVID. The data used for the experimental work was publicly available and comes from the sources listed. Data was pre-processed, images were standardized to 224 by 224 pixels, and the class weight technique provided by Keras was used to address the unequal distribution of classes. VGG16, Inception, and ResNet were the three transfer learning models chosen for image classification. Tenfold cross-validation was used in training the transfer learning models for both binary classification and multi-class classification. The ensemble learning technique used in the work is model averaging, as it is a simple way to improve the performance of machine learning algorithms. A holdout test set was used to enable the validation of the ensemble-based approach on unseen data. To empirically validate the approach and provide a baseline for binary classification, a similar approach to that of AN and UMBRA was performed. The binary classification had 7 different runs, 3 of which are based on individual transfer learning models and 4 of which are the different combination of transfer learning models using ensemble-based learning. Inception had the highest accuracy, just over 87%, for the single model, and the highest F1 score for pneumonia detection of the single models. With regard to the ensemble models, the highest accuracy is a combination of VGG16 and Inception, with approximately 88.9%, followed by the ensemble combining Inception and ResNet at 88%. The results for the ensemble for binary classification are not surprising, given the Inception was the best performing single model. The work was then further extended for multi-class classification to differentiate normal, pneumonia, non-COVID, and pneumonia COVID instances. The base models produce similar results to that of the binary classification. Inception outperforms the other two models with regards to accuracy. The F1 for Inception is higher than the other two models for both pneumonia non-COVID and pneumonia COVID classes, but it is lower when detecting normal chest X-rays. Ensemble models, including Inception, result in a higher accuracy, and the ensemble model that excludes Inception results in the lowest accuracy, being ResNet and VGG16. Unlike in the binary classification, where the ensemble of Inception and VGG16 have the highest accuracy for multi-classification, the ensemble of Inception and ResNet has the highest accuracy at 92.5%. VGG16's underperformance could be attributed to overfitting, as can be demonstrated by the loss in accuracy diagram. And this warrants fine-tuning of the network, which will be investigated as part of future work. Similarly, the same pattern emerged for F1 measure in pneumonia COVID and pneumonia non-COVID, classes where the ensemble of Inception and ResNet had the highest F1 measure. An encouraging finding is the improvement of recall in the detection of COVID-19 using the ensemble-based approaches when compared to the single models. Considering the impact of COVID and that of our approach is intended to assist radiologists, we can live with false positives as they do not contribute to potential spread, while false negatives would be a serious concern. However, the variation in recall across the three classes must be investigated further. So to conclude, we presented a ensemble learning-based approach with 3 transfer learning models, UG16, Resonate 50, and Inception V3. Inception performed all your models with an average accuracy of 87 and 89% respectively. For the ensemble-based approaches, binary ensemble saw Inception of VGG16 with 89.4% accuracy, and the multi-class ensemble saw Inception of Resonate with 92.5% accuracy. Now, our intent is to continue this work with model fine-tuning, and we're also carrying out clinical validation with an ongoing project collaboration with Lero, University of Limerick, and University Hospital Limerick. If you want any further information, you can check the website or you can contact me directly. Thank you for watching, and I'll take questions when allowed to do so.